Hello from the Forcetronics YouTube channel. Welcome to building a wireless sensor network with the nRF24L01 Part 6. Part 6, the final one. So at the end of this one, I'm also going to have the final product, the final board, the end device or router board that I've been sort of going through on these whole series. I'm going to actually offer it on my store if you want to purchase it. So it's not there, depending on when you watch this video. It's not there now. It should be there mid-July 2016. Also in July 2016, I'm going to be adding a lot more stuff to my store, including Arduino boards. So if you enjoy my videos, please go to the store, check some of the products out. All right, let's get started with part 6. So just a note, don't start at part 6 because I'm going to assume you know the project we've been going through. So if you haven't watched the other ones, I recommend you watch those first. So what are we changing, or what's new for part 6? So I created a surface mount design board. Actually, it has through-hole components still, but more surface mount components, and so it's smaller. Also, I switched the nRF24L01 libraries that I'm using. So I was using the Manic Bug ones. I'm now switching to the TMR-H20. Why I made the switch is because they're newer. Some people recommended it. And I actually leveraged his built-in sleep mode. So I was able to take that out of my code. So thank you to TMR-H20 for creating those libraries. There is one change though you have to make to the library, and I'll show that. And then also for this part, I created my own wrapper library called WS Node to make getting started easier. So, you know, if you're new to the maker world and you want to make a wireless sensor network, this wrapper will really help. It's specially made for this board, but it'll really help you get started, get something working really quick. Now, as opposed to the nRF24 libraries, this is not meant to be sort of a finished product library. It's really just to help you get up and running. And then if you want to do more complex stuff, you would just use this code as a starting point and build onto it. Okay, so here's an overview of the boards, and I didn't realize this picture is a little blurry, but it's good enough. So here's some final boards with the surface mount components on it. I have one for using battery power and one that's using AC wall power. And one thing I'll point out right away is this jumper. This 3-pin jumper allows you to choose between battery power or wall power. And so here you can see I have it in the wall power position. It's using this regulator, the LM317. You can see an LED comes on when you're using the wall power. On this one, I'm using battery power, so I have the jumper in a different position. I'm not using any of these components here, and you don't see that LED on because we don't want the LED draining the battery. You do see this LED on though, and that's because I just loaded the sketch onto this chip for the first time, and so it's going into settings mode, and I'll show an example of settings mode just again so you know how it works. I have 2 switches on here. This is the reset switch. This switch, if you hold it down at startup, you can enter settings mode, and settings mode, everybody should know, is you can set some of the settings on the chip through the serial monitor. And what this means is you can use the same code for each board. You don't have to have a special edition for each board because you can set the address, and you can set whether it's a router or an end device. Remember, a router allows other boards to talk through it. You probably don't want the router to be battery powered. An end device can be battery powered, and no devices can talk through it. What else should I mention? Here is the temperature sensor. I should mention that for this final design, I'm just using one temperature sensor. In the other board, I had footprints for other ones, and you could still leverage the design from the older board. Once again, this project's all open source, so I'll show you where you can get everything for it, including the PCB files. But I'm using the I forget what it is, ST something temperature sensor. You can look back at the other videos to see. But it's great because it can go down to real low voltage. So if you're running off the battery, we can go down to a real low voltage before we have to say the battery is dead. Here, of course, is the nRF24 transceiver module. Here's my little solderless breadboard area. So these pins, just like a solderless breadboard, are all connected together in case you want to play around with something and not have it actually soldered to the board. These 9 pins allow you to access some of the digital pins, analog pins. When I have this on my website, I'll have actually a header here. I don't have it in this one. These 6 pins are to program it. So an FTDI cable can plug into here. Boards, I have those on my store. You can use it to program. Everything else is pretty standard. I will mention though that remember this runs the Pro Mini 3.3 volt 8 megahertz bootloader. That's the Arduino bootloader that these will come with, and that this was designed with, I should say. Okay, let's take a look at the design in action. So here's the sketch, and I'll go over the code in a bit. But first I just want to show you the settings menu. So I have a node, the one you saw in the picture, that just had the bootloader loaded onto it. So if it just had the bootloader loaded onto it, it's going to automatically go in settings mode before it tries to transmit or join a network. So I'm going to open the serial monitor. Or actually, I just switched the serial monitor here. Now I'm going to actually open it. And you can see it goes right into the settings mode. And you can see it's just pulling out a value out of EEPROM. That's why it's saying 37777. The time interval defaulted to this. It defaulted to an end device. One thing if you might notice is I took out the internal reference voltage setting. What I did is I put it in the library, and if you want, you can sort of hard code it different. I just didn't want that to confuse people who might just be getting started. So I took that out of there, but you can still access it in the library if you want to change it. So do I want to change the address? The answer is yes. And what I want to actually change it through is I want to show an example of an end device talking through a router, and my router is going to be address 4. Remember, the coordinator is going to be address 0. So if I want to talk through address 4, I have to use an octal address that has to end in 4. I will mention that I still can't input octal numbers into this. So what I'm going to show you is, let me do this. So what I'm going to show you is if I want to enter an octal 14, so it's going to be node 1 communicating through router address 4. It's an octal number, base 8, 1, 2, 3, 4, 5, 6, 7, 8. If I want to convert it to a decimal, it's 12. So that's what I want to enter into the serial monitor. So sorry that still hasn't been fixed, and maybe I'll fix in a later one, but for now I'm not too worried about it. So here we go. I'm going to enter my 12. Do I want to update the interval? The answer is yes. I'm going to set it for 1 second, which is 0. And do I want to update the mode? No, I want to stay in end device, so I'll just put an N there. And then you can see it printed out the node address. So the new node address setting, as well as the time interval, which is 1 second, as well as the mode setting. Okay, so what I'm going to do now is show a coordinator. So I have a coordinator set up through an Arduino Uno, which has my nRF24, the Forcetronics shield on it, which you can purchase at my store. So I just have some coordinator code, which you can download, but it has it acting like a simple coordinator, grabs the data, and then prints it out to the serial monitor. So I have that on my COM port 6. Right now I have a router connected to it. So it's saying coordinator is online. The node this is from is node 4, address 4, and what it's doing is just printing out the temperature and the battery status. So 1 means the battery's good, which for the router is meaningless because the router's plugged in. I have it set for Celsius, so you can see it's hot in here. Now the one we just configured, I'm going to turn that on by jumping to the battery, and you can see that one is now starting to communicate. So you can see it's coming in as address 12. Remember, in octal it's 14, but it's being printed out as a 12. So once again, that's communicating through 4. Now notice once in a while they're pretty good. You'll see a 12 and a 4. They're each communicating every 1 second. Sometimes you'll see 2 12s or 2 4s. The reason that happens is I notice when you talk through one of the routers, oftentimes the transmit may fail. Now in the code, I actually have it do it twice. So if the first transmit fails, it tries again, and that's why you see 2 doubles. But I did find with the network that sometimes it can fail to go through the router. Usually it's pretty reliable, as you can see, but you can't count on it being exact as far as the timing. Okay, let's look at the code. So here we're looking at the example sketch, which you can download from GitHub, and I'll show you where. And then also I'm going to call in my wrapper library. So if you remember the other parts where I showed all the code, that a lot of that code now is in these wrapper libraries, which you can access. So the way I have it set up is the libraries are in the same folder as this sketch, so I use the quotation marks to call it. You can also see them right here. I'm not going to go through the libraries, there's plenty of comments in there, but just to show you, so here's the sketch and here's the libraries. So I call the libraries. I still need to call the nRF24 network and the rf24.h, as well as these libraries. I then make my objects, my rf24 objects, my rf24 network object, and then I feed both those objects into the ws node library so it has a reference to each one of those and it can access them. Here I start it, I do a node begin. You want to do this one first before these others because this one is what gets the address from EEPROM. So you want to call it before you call radio.begin, or really before you call network.begin. And then you can see I access the library because the library object's name is wnode, and then I do .this node, which is the address. Then what I do is I set it for Fahrenheit. And so if you actually saw, one of them I had set for Celsius when I showed the example, and the other one I had set for Fahrenheit. So you can just call this function to set them for Celsius or Fahrenheit. And once again, you can go into the libraries to look at all the different functions. Then, and this is why I made this wrapper to make everything pretty easy, you can then just go to this function, which is send sensor data. So based on whether you're a router or an end device, you'll send data and you'll go to sleep, or you'll send data and you'll just loop until it's time to send data again. So what this function does, it actually will communicate with the coordinator. It's going to get the temperature reading from the temperature sensor and also check the battery status. It's then going to send the data to the coordinator. Now, if you're in end device mode, it will then go to sleep. So if I'm transmitting every second, I'll send my data, I'll go to sleep for 1 second, and then the rest of this loop will execute until you get back to this. If you're in router mode, there's a timer check. So it'll get to this function will check the timer. If it's not time to transmit, this loop will keep going. So that's the difference between router and end device when you're using it in the code. Inside this function has the network update. So if you're in router mode, you don't want to stop this function from executing because you want to keep updating the network so you can pass any data from an end device through the router. Now what I did is, notice you don't have to feed any data, this handles it. If you want though, there's another function here that I have commented out that allows you to send your own data. So here's an example. I'm actually, in this example, I just show you getting the same things that this function is sending, but I create a payload, a structure. Then you can see I use these two function calls, wnode.get stt S75 whatever temperature, that's the name of the temperature sensor, and then I also do get check the battery. 0 is low battery, 1 is a good battery. I feed that into the payload, I then send it out, and I get the same exact functionality that I get here. The whole point of this function though is if you want to do a payload with other stuff than just these two things, you can cater it to your needs. But you can see with the wrapper, the code gets pretty simple if you just want to get started. I also have the sketch without these libraries that has the full code on GitHub as well, which you can access. Okay, something else I need to show you before we stop here. The TMR H20 RF24 network library. If you download that from GitHub, and once again, that's what I'm using here. You want to use this, not the Manic Bug one. If you download this from GitHub, he or she, I should say, RF24 network /config.h, which you don't call in your sketch, but it's, his library calls this. And this allows it, the reason he has this is it basically allows you to set things up if you're using a Raspberry Pi, if you're using different types of Arduino boards. One thing you need to do though is, because I'm using the sleep functionality, when you download this line of code is actually commented out, enable sleep mode. So you need to remove the comments so sleep mode will work. If you don't do that, the sketch and the library that I'm providing will not work correctly. What you're seeing is I have it opened in Visual Studio. You can open it in using Arduino IDE, or you could just open it as a text file, get rid of those comments out, and you'll be good to go. And then lastly, I just wanted to show you the GitHub, where you can get on GitHub if you search Forcetronics, or if you just search this. Here's all the different files. Here's the library files. Here is my Eagle files. This is the SMD. This is the older board. That's through-hole if you want to leverage that. Here is the example coordinator code. So what I just showed, where the simple coordinator is just getting data from the sensors. Once again, this project focused on the router and the end devices. Designing a fully functioning coordinator is going to be up to you. Maybe I'll do something in a later version. Here is the sketch that doesn't use the library, that has all the code from the library in the sketch. And then here's the actual sketch that I showed you, the simple one. So you can download this all from GitHub. Okay, that is it for part 6, the last one, for basically building a wireless sensor development board, a router or end device based off the nRF24. This is meant to be totally open source, so you can build it yourself. If you like this project and you want to leverage the board I'm using, you can purchase it. The price will be pretty low. I don't have the price exactly yet, but it should be here by mid-July. It'll be called the Wireless Flex Node, and then I'm also going to have some Arduino boards and other products, more products up on my store in July 2016. Anyway, thank you for watching.